the last section, section 2.1, we were focusing on trigonometric functions of acute angles. Notice almost everything we did in the last section involved acute angles. Well, we're going to go one step further in this section and look at trigonometric functions of non-acute angles. Before we do that, we have one new idea we need to deal with here, and that's really the only new thing in this section. A reference angle for theta is the positive acute angle made by the terminal side of theta with the x-axis. This book is using the notation theta prime for the reference angle. I'm not sure if that's standard notation. I'll just always say the reference angle. I won't use the notation theta prime. Well, let's draw a picture in each of the quadrants to see what this is saying. Okay, so suppose I had an angle. It could go around 100 times and it stopped in the first quadrant. So the terminal side looks like this. And then, we draw a triangle picture with the vertical line as always. And so again, I don't care what the original angle theta was, I'm looking for the reference angle for theta. Well, the definition says it's a positive acute angle. Okay, so keep that in mind, the reference angle is positive and it's acute. And it's the angle made by the terminal side of theta, there's the terminal side of theta, with the x-axis. So it's an angle between the terminal side of theta and the x-axis. Well, that maybe is it, right? There's the x-axis, there's the terminal side, but there's a terminal side and there's the x-axis over here too. Could it be this angle? Well, no, because remember it has to be acute. So this can't be the angle, so it has to be the angle here. Right? So my original angle theta, whatever that looks like, if it stops in the first quadrant, the reference angle for that original angle is that angle right there, and it's positive, so it's going to be the acute angle right there. What if we stopped in the second quadrant? So you go round and round and round and round, and then your angle stops in the second quadrant. So there's the terminal side. Let's make a right triangle like always. Now where's the reference angle for that angle? The angle that stops here, whatever it was, the 1,000 degrees that stops here, where's the reference angle? Well, it's the positive acute angle made by the terminal side with the x-axis. Again, it can't go from here to there because that would be obtuse. So it must be the angle right there. Now, do you see what I'm drawing here? The picture I'm drawing is basically the same as the little butterfly picture I did, a couple sections ago. In the third quadrant, your triangle is going to look like this. Where's the reference angle? It's from the terminal side to the x-axis. It can't go to there. It's the angle here. And in the fourth quadrant, same thing. It's the angle here. So whenever we were using the definitions opposite, adjacent, hypotenuse stuff, I always said it doesn't matter what the original angle is. We're using the angle in the triangle next to the origin. That's what we were doing. We were using the reference angle. So it doesn't matter what the angle is. When I said opposite, I was talking about opposite that angle in the triangle. Opposite that angle, that, or adjacent to that angle, adjacent to that angle, adjacent to that angle. So even if the angle, your theta goes, 2,000 degrees and you stop somewhere, the reference angle is the angle in the triangle. So we've been using it already, we just didn't call it the reference angle. So there's your reference angles, here or here or here or here. The angle in your triangle that you draw next to the origin. Again, that's why I always said, draw your triangles with a vertical line. There's your reference angle. Okay, so as an example, the next four say, find the reference angle for each of the following. Well, A is 140 degrees. Let's draw a picture of it. Right? I mean, I told you there's where you find them, so let's draw a picture. You just need a rough sketch here. Where's 140 degrees? I always say, is it all the way around? Is it halfway around? It's less than 180, so it's not halfway, but it's more than 90. It's somewhere in the second quadrant. That's really all we're concerned about, what quadrant. You don't have to be that precise. So 140 is over here in the second quadrant somewhere. Draw my little triangle. There's 140 degrees. Now, where's the reference angle? The reference angle is the angle in the triangle here. Well, how would you figure that out? Halfway around is 180 degrees. We've used up 140, so the reference angle is 180 minus 140, or 40 degrees. So I didn't give myself a, the reference angle is 40 degrees. Right. So the original angle is 140. The reference angle for 140 degrees is 40 degrees. Okay, let's do B. Now, in which quadrant is negative 175 degrees? So negative means we have to go clockwise. Alright, so that's going to be in the third quadrant, isn't it? So 175 is almost the 180. So there's negative 175 degrees. So the reference angle is the angle right here. Alright, so how would you figure that out? Well, all the way halfway around is 180 degrees. We've used up 175. So what's left in that angle, that's 5 degrees. Now, is the answer negative 5 because we started with negative 175? Should the answer be negative 5 instead of 5? Well, no, because remember, reference angles are positive. Okay, so the sign on 175 degrees didn't matter. So what's the reference angle? The reference angle in this problem is 5 degrees. So that little angle right there is 5 degrees. Okay, pause the video and see if you can do the next two, and then I'll do them. We'll see if we get the same thing. Okay, so for 422 degrees, now that's more than once around. So if I go all the way around, I've used up 360 degrees, haven't I? So how much more do I have left to go? So 422 minus 360 is 62 degrees. I have 62 more degrees to go. That'll put me in the first quadrant. So this is a picture of 422 degrees. Now what angle am I looking for? The reference angle is the angle here. Well, didn't I already figure that out? Right, I said all the way around was 360. How much more do I have to go? That was 62, so that's the answer here. So I actually figured out the reference angle in drawing the picture. So the reference angle is 62 degrees. Good, that's the answer for that one. And then the last example here was 345 degrees. 345 degrees is more than 270 and less than 360, so it's almost all the way. It's in the fourth quadrant. So this is 345 degrees. Okay, well, how would you figure out the angle here? The reference angle is this angle right here. And so all the way around is 360. We've used up 345, and 360 minus 345 is 15 degrees. So here the reference angle is 15 degrees. Okay. Often I will have students say, okay, so if it looks like this, you subtract 180. If it looks like this, you subtract it from 360. And if it looks like this, why would you want to memorize all that? Just if you draw a little picture, you can figure out what to do. You know, oh, that's 140 to here is 180. So subtract 140 from 180, you get your 40. Notice in drawing the picture here, I figured out the reference angle, right? Oh, you know, all the way to here would be negative 180 degrees. I've used negative 175, so that angle has to be 5. I mean, all the way around is 360 minus 345 gives you what you want. If you just draw the picture, or even imagine the picture, you can figure out what to add or subtract. I don't know if it's worth it to memorize. If it's in the first quadrant, do this, or second quadrant, do this. I would just draw the picture. Okay, so the next examples use this and stuff we did in the last section. So this is the only new thing. It's finding the reference angle. So the next example says find the exact value for each of the following. So A is cosine of 135 degrees. Okay, so again, I mean, we're interested in 135. Once you draw the picture, you could do all 6 trig functions. Right? So normally I would ask for 2 or 3 of these, not just one trig function at a time. Okay, so let's draw a picture of the angle. Where's 135 degrees? 135 degrees, it's more than 90 and less than 180, so it's in the second quadrant. So there's 135 degrees. What do you think we're going to find next? I can't imagine. Well, maybe since we just did it, we're going to find the reference angle. Right? We're interested in this triangle here, and we know nothing about it right now. I don't know any of the sides. I don't know any of the angles except for the 90 degrees. Well, what's the reference angle? All the way to here, halfway around is 180 degrees. We've used up 135, so the reference angle is 180 minus 135, which is 45. Now, frankly, that answer should not surprise you. The problem said find the exact values. That means don't use the calculator and punch in and around. So we have to do stuff without the calculator. What are the only angles we know how to find trig function values for without the calculator? quadrantals and special triangles. Okay, so if it says find the exact value at this point in the course, and you do this and you get 20 degrees here, that's a clue. Either, I've given you a terrible problem that doesn't make sense at this point, or you've copied something down wrong, or you subtracted something wrong. So the only ones we can do by hand without the calculator are quadrantals and angles that involve special triangles. So the reference angle has to be an angle in one of our special triangles. Okay, well, we know the numbers that go on this triangle, right? 1, 1, square root of 2, those are the three numbers. Square root of 2 is the largest number, so it goes on the hypotenuse. And we have a 1 and a 1 here. Now, we mentioned this before, so you have to be careful. So the extra step we have here is do the angle, find the reference angle. In the last section, we did 30 and we did 45, which were both in the first quadrant. Now we're going outside the first quadrant. What do you need to check for at this point? Do any of the numbers need to be negative? Yes, the x value, because we're in the second quadrant. This is the point minus 1, 1. Don't forget that step. Okay, whenever you draw a triangle picture, check to see if any of the numbers need to be negative. Now, we could do all 6 trig functions if we want, but they only ask for 1. And what's the cosine? It's adjacent over hypotenuse, or x over r. So it's a minus 1 over square root of 2. Again, you don't have to rationalize for me. Okay, so the only new thing is we need to find the reference angle, label your 3 sides with the numbers on your special triangle, and don't forget to check for negatives. B says cosecant of negative 120 degrees. Okay, so negative 120. Where's that going to be? Well, we're going in the, downward. It's a negative angle. So it's between the 90 and the 180. So there's negative 120 degrees. There's my triangle picture. Okay, what's the next step? I mentioned this in a previous lecture. Students have problems on exams and quizzes because they don't remember the steps. All right, so I sketched the angle. What's the next step? Find the reference angle. So halfway around is 180 degrees, negative 180 degrees. We've used up negative 120. That leaves 60 left. Remember, reference angles are positive. Okay, so this is our other special triangle. If it helps, you can put the 30 degrees down here. And what are the 3 numbers? 1, 2, square root of 3. I always do the hypotenuse first. Of these 3 numbers, 2 is the largest, so that goes on the hypotenuse. And 1 is the smallest number of the 3, and so where does that go? It goes opposite the smallest angle. The 1 is here, which means the square root of 3 is there. Okay, don't forget to check for negatives. We're in the third quadrant. This point has the coordinates minus 1 minus root 3, so those are both negative. And now we could do all 6 trig functions if we wanted to, but they only asked for 1. What was the definition of cosecant? Right, cosecant was hypotenuse over opposite, or it was r over y, and so this is 2 over negative square root of 3. Notice on both of these problems, if you forgot to check the negatives, you would have gotten part of it wrong. So don't forget to check for negatives. Okay. Okay, so again, follow the steps. Have you noticed I'm doing the same thing on every problem? So the next one says tangent of negative 270 degrees. So tangent of negative 270 degrees. Okay, what do we do first? Well, let's draw a picture of negative 270 degrees. Okay, so we're in standard position. You notice I haven't been drawing my initial side, I just assume it's always there. Tangent, where's negative 270 degrees? Well, it's negative 90, negative 180, negative 270. Okay, so my initial side is here, my terminal side is here. Which special triangle is this? Well, it's not a special triangle problem, as I mentioned at the end of the last section. We stopped, the terminal side is on an axis. It's a quadrantal problem. So I threw this one in the middle of this section to remind you, not every problem is solved with a triangle picture. Negative 270 degrees, the terminal side's on the positive y-axis. This is a quadrantal problem, so what's the procedure? I'm going to pick the point 1 unit away from the origin, so that's 0, 1. Now, how do we get tangent? Remember the first value when you do this procedure, picking points 1 unit away on the unit circle, cosine's the first value, sine's the second value. So how do you get tangent? Remember the quotient identity is sine over cosine is tangent. So this is cosine and sine, and so it's sine over cosine, 1 over 0 is undefined. So there's no triangle picture, no special triangles involved in this one. That's why I say draw the picture and see what happens. And then D says find the sine of 405 degrees. Okay, pause the video and see if you can do that one on your own, and then I'll do it and we'll see if we get the same answer. Okay, where's 405 degrees? That's more than once around, so all the way around is 360. And now how much is left to go? Well, I've used up 360. 405 minus 360 is 45 degrees. So that leaves me in the first quadrant, just a little bit more to go. And notice doing that calculation to figure out what quadrant I'm in, I know the reference angle is 45 degrees. So the angle we're finding the sine of is 405 degrees. The reference angle is 45. And what are the numbers on the 45, 45, 90 triangle? 1, 1, square root of 2. Square root of 2 is the largest of the three, so it's on the hypotenuse. The other numbers are 1 and 1. Again, the 45, you know the two legs are going to be the same. Okay, if we check for negatives, there's no problem because we're in the first quadrant. Every x and y are both positive, so we don't have to do anything for the negatives. And now we can answer the question. Sine is y over r, opposite over hypotenuse, so that's 1 over square root of 2. Okay, same procedure as before. Notice the 4 examples all involved a special triangle or quadrantal. That's all we're going to be. That's all we can do without the calculator right now. Okay, the very last problem, example here, it says find all values of theta if theta's in the interval 0 degrees to 360 degrees, so just in one revolution, and secant theta is minus root 2. Okay, now, how is this problem different from the ones we've been doing? Notice in these problems, they gave you the angle. We drew the picture with the angle, put the sides, and used the sides to figure out the sine here, trig function value. Notice in this one, they're giving you the trig function value. They're starting with this, and you have to figure out the angle. It's basically these problems we just did in reverse. Okay, so the ideas are the same, but the procedure's in reverse. So I don't know what theta is. I can't draw theta, right? Because they didn't give it like here. They told me 405. I draw 405 degrees. Here they gave me the trig function value. Well, let's just use this to draw pictures. Right? So here we had the angle, we found the reference angle, we found the sides, we found the trig function value. So here we're going to go backwards. Okay? So let's think about secant theta is negative root 2. Think of that as being over 1. Can we draw a picture of theta even though we don't know the value of theta right now? Well, secant is minus root 2 over 1. In particular, secant's negative. If you think back to the little butterfly picture I did several sections ago, where is secant negative? We know secant's negative in exactly 2 quadrants. And we're only going 1 revolution. So in 1 revolution, there's going to be 2 answers. If this is at 0 to 720 degrees, that would have been 2 times around. So we would have been in 2 quadrants twice each. So there would have been 4 answers. Okay? But from 0 to 360, secant's negative in 2 quadrants. So there's going to be 2 answers here. Now, I know secant's positive in the first. Every trig function is positive in the first, so it's not in the first. So where is secant negative? Well, secant is negative in the second quadrant and the 3rd quadrant. Because remember, secant, even though the negative is with the root 2, remember secant is hypotenuse over adjacent. And the hypotenuse is a negative. The adjacent side has to be negative, so it can't be first or fourth. Right? So when you did the homework in that previous section with the butterfly picture, hopefully you got quick enough at that you knew that secant was negative in these 2 quadrants. You cannot spend 10 minutes figuring out what quadrant this is. That's the first step in this problem. You have to be able to identify quadrants pretty quickly. Okay, so let's notice here they gave us we used the angle to get the reference angle to get the numbers. Now we're going to use the numbers to get the reference angle. So it's just backwards. So secant is hypotenuse square root of 2 over adjacent, and square root of 2 over adjacent. Now here the adjacent side is negative. So r isn't negative. Well, do you know what the other sides are here? These are the numbers from our special triangle. It's that. That's a 1 and that's a minus 1, isn't it? because you recognize the 1 and the root 2. It's two numbers of that special triangle. The other one's the other number. And notice that this is 1 because with this in the second quadrant it's -1, 1. In the third quadrant it's -1, -1. All right. So now, what's the reference angle for these triangles here? Well, it's our 45, 45, 90. So this angle's 45 degrees and this angle's 45 degrees. So they're congruent triangles, so the two reference angles are the same, 45 degrees. Okay, so now we just have to go back to the original theta. Right, so the answer here is not 45 degrees. Theta, 45 degrees is the reference angle. Remember, theta is measured from standard position. So this is one solution, and from here to here is the other solution. So the answer is not 45 degrees. The reference angle is 45 degrees. So how do we get the angle from the angle in the second quadrant from here to here? Well, all the way to here is 180. You back up 45, that gives you the angle for theta that you want. Okay? And 180 minus 45 is 135 degrees. So that's this angle right here. Right? So all the way to here is 180. You need to back up 45. So there's your 135. Now, how do we get the angle in the third quadrant from here to here? Well, that's 180 plus 45, right? 180 plus 45 gets me to here, and that is 225 degrees. So those are your two answers. So you see, we basically did the procedure in reverse. If I had told you 135, what would you do? You would have drawn 135 to here. You would have found the 45 degrees. You would have figured out the three numbers, and then used the three numbers to get that. Notice what we did. We asked ourselves, where is secant negative? Secant's negative in the second and the third, and so we drew a picture of the triangle. Use the numbers to put on the sides of the triangle. Use those numbers to get the reference angle, then use the reference angle to get the angle in standard position. So it's basically those problems in reverse. Okay? Okay, so that's that section. There's only one big idea, and that's reference angles and going backwards.